This is a lesson on circle theorem. This tutorial is being presented by Peter Smith. The goal of this lesson is for you to recognize and apply various theorems involving inscribed angles of a circle. Here are a few basic facts you need to remember before looking at circle theorem. 1. The distance around a circle is called its circumference. 2. The radius of a circle is the distance from the center of a circle to any point on the circle. 3. The distance across a circle through its center is called its diameter. 4. A chord of a circle is a straight line segment whose endpoints both lie on the circle. Note that a diameter is a special type of chord which goes through the center of the circle. Five. The segment of a circle is the region bounded by a chord and an arc. 6. A tangent to a circle is a line segment which touches the circle at one point. It does not cross the circle, it just touches it. 7. A sector of a circle is the portion enclosed by two radii and an arc. Now, let's look at the theorems in regards to angle properties of a circle. You may pause the video at any time and take notes. The theorems are as follows. Theorem 1. Angle at the center. The angle formed at the center of the circle by lines originating from 2 points on the circle's circumference is twice the angle formed on the circumference of the circle by lines originating from the same points. Here, I showed you 4 ways in which this may be drawn. In each of these, the angle at the center is twice the angle at the circumference. Note that these lines are originated from the same points, P and Q, forming angles at the center and circumference of the circle. Therefore, angle A is twice angle B. Theorem 2. Angle in a semicircle. Angles formed by drawing lines from the ends of the diameter of a circle to its circumference form a right angle. Therefore, angle C is a 90-degree angle. Theorem 3. Angles in the same segment. Angles in the same segment are equal. In other words, angles formed from the same chord to the circle's circumference, in the same segment, are equal. This purple line is a chord. A chord is a line segment whose endpoints both lie on the circumference. It does not go through the center of the circle. A chord divides the circle into segments. Here are your 2 segments. These 2 marked angles are formed from the same chord to the circle's circumference, in the same segment. These 2 marked angles are equal angle. Theorem 4. Opposite angles in a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral add together to give a total of 180 degrees. In order for you to identify a cyclic quadrilateral, you must see 4 vertices touching the circumference of the circle. Now, angle A and angle B are 2 of the opposite angles in this cyclic quadrilateral. These 2 angles are supplementary angles, meaning they must add together to give a sum of 180 degrees. Theorem 5. The alternate segment theorem. An angle between a chord and a tangent equals to the angle subtended at the circumference in the alternate segment. This line is the chord, and this is the tangent. The angle between a chord and a tangent equals to the angle subtended at the circumference in the alternate segment. The angle subtended at the circumference is the angle which sits on the chord. Therefore, note that the 2 red angles are equal. Also, the 2 green angles are equal. Theorem 6. The exterior angles of a cyclic quadrilateral. The exterior angle of a cyclic quadrilateral equals to the interior opposite angle. Therefore, note that the two red angles are equal. Also, the two green angles are equal. Theorem 7. Angle between a radius and a tangent. A tangent to a circle is a straight line which touches the circle at only one point, so it does not cross the circle, it just touches it. A tangent to a circle forms a right angle with the circle's radius at the point of contact of the tangent. This is the radius, and this is the tangent. These two form a 90-degree angle at the point of contact. Theorem 8. Line from the center to the midpoint of a chord. A line from the center of a circle to the midpoint of a chord is perpendicular to the chord. In other words, the two lines meet at a 90-degree angle. Theorem 9. Two tangents to a circle. Two tangents to a circle from the same external point are equal in length to the point of contact to the circle. So, these two tangents are equal from the point A to where they touch the circumference of the circle. Okay, guys, these are some of the circle theorem rules you will have to apply whenever you are given a problem. Knowing these rules is important, but knowing how to apply these rules is what makes you powerful. Therefore, it is very important that you keep practicing these rules over and over, until they become familiar. Okay, you have just watched a lesson which was presented by Peter Smith. Please join me in another lesson where we learn more important math topics. Let us think of education as the tools of developing our greatest abilities, because in each of us there is a private hope and dream.